65 meters above sea level. Okay, so I'm going to write that in. This road is at 65 meters above sea level. That means where there's a 65 contour and it meets the edge of the road, I don't have to do any work. If I look at the contours to the right, they are lower than the road of 65, so therefore I'm going to have to fill in this space, and I'm going to have to, these contours are above the road, therefore I'm going to have to cut away. So I can kind of follow this guide here that this section is a cut section. Let me just double check, 65, yeah, this is a cut section, cut and fill, so it should be almost symmetrical. It is recording, no, it's not, it's recording through a different app, yeah. Okay, so, is all okay to see that with light-wise and stuff, yeah? Yeah. Everything's good, okay. So, the contours are in 5s, so for my fill activity, I'm going to take this ratio and multiply it by 5. That gives me 5 is to 10, which means my spaces for parallel lines will be 10s. So, I'll take my ruler and I'll space them out by 10s. And I'll draw in my red lines. Okay? As I get further away from the road for fill, it means I'm getting lower and lower and I have to fill in more material. So if the road was at 65, this contour would be 60, then it would be 55, then it would be 50, and then 45. All I simply have to do is where those red numbered lines meet the contours to fill them in. So 60 meets 60 there, 55 meets 55 there, 50 meets 50 here, and 45 meets 45 roughly around about there. So my fill activity, which should be in red, will go like that. Okay, and it would start coming back on itself if I was to hit the 50 contour here, because it's rising back up. That's why you see that bend there. It would start bending back, but I've ran out of map, so I don't have to worry about what's not on my map. Do we understand that? Okay, and that's my fill. If you want, for clarification for yourself, you can colour it in if you wish. Whatever's in green is the same on both sides. Okay, and as Daniel said, the size of that map would affect it slightly, but what you should have is this should be maybe closer together if the map was bigger. Okay, so that's my fill activity. Now I'm going to go for cut. Contours again are in 5s, so I'm going to multiply this ratio here by 5, giving me 5 is to 5, which means my spaces between my parallel lines should be in 5s. So from the edge of the road, I'll step up by 5, 10, 15, 20, 25, and I might just go 30 just in case. Parallel lines either side. Okay, cutting. As you get further away from the road, you're going higher and higher up because you have to cut away more material. So that means the numbers should be increasing. If this is at 65, that means that this one's going to be 70, 75, 80, 85. Same on this side. With the same work. And then all I'll do is wherever those blue numbered lines hit the according contours, we'll tap them in with a dot. So 70 meets 70 there, 75 meets 75 there, 80 meets 80 here, 85 meets 85 there, back to 80 again. So I need to stretch this on a little bit. That's where it hits 80. So for my cut activity, it should look like that. Okay, and if we wanted to, we can just colour this in a different colour. That's my cut activity for that section of road. Doing the exact same on this side, working with the contours. So 80, where does 80 hit 80? It doesn't. So 70 doesn't meet 70. So it's actually fill here we have to do, is it? 65 is there. 65 is here. So 70 doesn't meet 70. There's the 80 contour. 80 meets 80 there. 85 meets 85 there. 75 meets 75 there and there. So for this is 80 again, then it'll probably meet somewhere there. So for this, I'm going like that. Okay, does that make sense? That's my straight road then, section done. This would be a cut activity here as well if I was to do it, so I'm just colouring that on purple just so we can see the comparisons and you can see the map of that going that way. So I'm just going to stop that. Bounce back into this here, okay? What I did the other day was I looked at the question. The question said that B is at 65 metres above sea level, which is here. It doesn't tell me what height D is at, or doesn't give me a second height along that road, so therefore I have to find that second height on the road. Now it told me that the slope is 1:15, which means for every metre you go up, you have travelled 15 metres along horizontally. So your triangle is essentially 1:15, okay, if that makes sense. So what we're going to try to do is we're going to try to multiply that and make it a very large triangle, something similar to our set square, okay. So we're trying to get that slope and we're getting that second known point away on the road that links in nice and closely to that ratio. So from B to E, I've moved 150 millimeters. Okay, you could go 75. 75 would be halfway, all right? And therefore, for 75, I would have moved 5 meters up from where I originally started above sea level. But for 150 meters above, what has happened is I've gone up by 10 meters, okay? So that's the triangle I have done there. Walked along 150, which means I've gone up from 10 from where I started. I did start at 65, so therefore I ended up at 75. That's step number 1 on my sloped road. Step number 2 on my sloped road is I have to complete arcs. Now before I do both arcs, I need to figure out, do I need both arcs? So what I've done here is I've looked at the contours of the map and I've looked at this section here where E is. So E I know is 75 above sea level, and the contours that are in that area are below 75. So I definitely know I'm going to need a fill. And then I've looked at this B area down here, and I've looked at the contours around there, and I've noticed that they're higher than 65, so therefore I'm also going to need cut. I might only need a small amount of one and a large amount of the other, but I do need both. So then I'm going to figure out my slope. Yeah. Is anybody else going, yeah? So whoever's going is going, yeah? Okay, so the second thing then is I need to figure out the size of these arcs. Now what we've done is I'm going to create a cut arc. I look at the ratio for cut, and the ratio is 1:1. That's what was provided for me. Now, how do I work out what size to put my radius for the cut arc? First thing is, it's cut at the butt, which means at the bottom height, and I need to work out the radius here. So I take 1:1. Now my ratio for when I'm doing the arcs is the height difference between the 2 points, between B and E, the height difference between there is 10. Okay. Is to the radius, okay, and that's what I'm looking for. I'm looking for the radius, so that's the missing number. So if I take my 10, multiply it by that number in the ratio that was given to me, I will get my radius. So the radius for cut arc is 10 millimeters. So down here, I measure that to be 10 millimeters from the edge of the road out. Okay? That is a radius of 10. Let me just write that in. If I get my pen, I'll just try and write here, or equals 10. Then for E, okay, for the fill ratio, this is cut at the butt, so that's a cut arc for cutting at the butt, filling at the hill. The size of this arc, our fill ratio is 1:2. Again, the height difference between B and E is 10. 10 times 2 is 20. 20 equals the radius. So I go over to E at the edge of the road. I then put down 20 millimeters, or equals 20. Okay? The red line is my fill. The blue line is my cut. Blue is tangential to the arc, red is tangential to the arc. And I'm going to write on them now the numbers that apply to them. So the numbers that apply to those two lines are the following. So this blue line hits the road here at 75, so therefore that's going to be a 75 line. The red line hits the edge of the road here, therefore that's going to be a 65 line. So I'll write on it 65. Now just take one activity at a time. So you're either doing cut or you're either doing fill. What you can do now, which can be, which might help, it doesn't generally, but you can untape it and maybe just rotate it around a little bit. But you're doing two different sets of parallel lines, so you're going to need sliding set squares anyway, so it's not really that beneficial to untape it. So what I'm going to do now is I'm going to now do my spaces between these red lines, very much like what I've done here. The red lines here are spaced out at 10s, the blue lines are spaced out at 5s. We have to now do the exact same thing there for these two sets of lines, and this is why colours are useful. So for my red lines, the spaces are 10s, so I'm going to go 2 inside and I'll go 4 outside. Okay, I draw all them parallel and I'll draw all them in red. So set it up to my original red line, tangential line, bring it to the inside, draw that line. Where is that line going to hit the edge of the road? It's going to hit it 5 meters above where it started. Now if I do this next parallel line, it should hit the edge of the road here perfectly at E. And it does. So that there I know is associated with the 75 contour, that's associated with the 70 contour. Keep going with my red parallel lines and my numbers are now reducing. So this is going to be associated with the 60 contour. This is going to be associated with the 55 contour. This is going to be associated with the 50 contour. And there's no 45, so I don't need to put them in. So that's 60, 55, 50, and I don't need my next one. And all I need to do now is put in my dots where those numbered red lines meet the numbered contours. So the 50 contour here meets there. 55 meets here. 60 meets there. 65, it goes back to 55, so it comes back up. 55 meets 55 there. Then to 60 again, so it comes back down to 60. Then 65. Then 70. Just tracking and tracing and putting in my dots. And then 75 there. Okay? So this is the shape that it takes on. Alright? And you can keep going over this side as well if you wish. So the 65 will hit the 65 contour here and here. It doesn't come across the 60s, so that red line will hit 70 there and there. And then the 75, if I continue the 75 line on, it hits 75 there and there. So that's kind of my cut work there. Okay? And now I'm going to do my fill work. Alright? So my fill work then is in blue. Same thing kind of happening. I'm now concentrating on blue lines. Colours are really important here. So my blue lines then will be parallel to this one. The spaces for the blues are 5s like they were previously. So I'll step out parallel to that blue line in 5s. 1, 2, 3, 4, 5 on the outside. 1, 2, 3 on the inside. Set it up parallel to the blue line and draw them in. Now I know that first blue line is labelled at 75 because it hits the road at 75. So as I step further away, it's going to be labelled with an 80 contour. The next one's going to be 85. The next one's going to be 90. We don't have any 90 contours on it, so I don't need to go out that far. So that's going to be 80, 85. The next one stepping in from that is going to be 70, 65, and 60. So again, all I do is wherever those numbers hit the corresponding dots, I'm going to put them in. 75. Now there's a bit of an overlap here, so there's two different types of work going on, so I still have to have them overlapping. Okay, that work is important. 75 to 75, 70 to 70, and just write my numbers on these just to make sure I'm doing it right. 70, 65, 60. So wherever the 70 comes and hits 70, then wherever the 65 hits the 65 there and there, then I'm back up to 70 again, and then 75 hits 75 here, 80. I need to continue this on because these numbers are repeated along this way. So in this gap is where I need these numbers. So I'm basically filling in the gaps between the red sections there that I've already done. Okay, so next number is 80. Where does 80 hit 80? Hits it there. Where does 85 hit 85? Hits it there. Where does 80 hit 80? Where does 75 hit 75? Hits it there. Where does 70 hit 70? Hits it there. And I have spoken to you before about overlapping lines, so you'll see it happening here where the red and blue overlap each other. Very important to have those overlapping lines. So that's my work done for the sloped or inclined straight bit. If you wanted to colour it in, you can colour it in. I have fill coloured in green. I can colour this in green. Again, you don't need to do this for the exam. It's just for clarification and revision purposes, really. Okay, and a bit of clarity on what we're doing. But if it helps, especially for revision, please put it in. Purple then is for our cut. So I'm going to put that in, and all of that area needs to be cut. It is overlapping with the slope or with the level road, but that's good. It's supposed to do that. Okay, and that's cool. Now, we talked about almost symmetrical, didn't we, Daniel, earlier on or the other day? So you can see that this comes out and back in, goes out and back in, comes out and back in. Then you have another lump kind of there, same lump here, that lump and that lump. So it's almost symmetrical, and if I had probably printed it out proper size, not my fault, computers, by the way, it probably would have looked better. Is that okay?
Why is the radius of the arc 20 and 10?
Okay, so fill is 1:2. So the distance, so the ratio, that's a really good question, right? So how do we work out the arcs? So the way that the ratio works is the height difference between my 2 points on the sloping road, which is B and E, yeah, is to the radius. We have to apply that ratio to either cut or fill. Our fill ratio is 1:2. Okay, so it's going to end up 1:2. What's the number I put in here for B to E? What's the height difference between B and E? 10. 10 by 2 is 20. Okay, good question. All right. So that's that. Now I'm going to move on to this part here, P, Q, and R. And you'll notice it already gives you the strike, which saves me work. Okay. What does it ask in the question? Adrian is giving me his here, I think. So, this is it here, isn't it? On the map, points P, Q, and R are outcrop points on the footwall of a stratum of ore. Point S is a point on the head wall. So we're looking for thickness here, okay? And the strike of the stratum is given. Find the dip and thickness of the stratum. Dip is basically angle, okay? And you have done this before. This technique that you're about to do here, or about to show you, comes up very, very commonly in the short section under the oblique plane. It's basically the angle of inclination with the horizontal plane. Jake, does that make sense to you? So if I took a set square here and I asked you what angle does that make with the ground, that's the dip. Okay? Now how do I see the angle between my set square and the table at any time? If I put my set square sitting here, what angle is this with the table? Well, the way I find it is I will look along this horizontal line with one eye closed and I'll see the angle that's being created here. Yeah? This horizontal line is the strike. Okay? So we have our strike. We're going to look in here. Here's my little eyeball. Looking in that direction. And it means I'm going to create my view in this blank space up here. So, I'll take my strike. I'll take my second set square to go 90 degrees to it. This will then become my x1, y1. x1, y1. All of my points are going to be brought at the exact same angle as the strike. So P, and I'm going to call this point 1, so P1. No, sorry, R1 is it? R1. Change color here. Q. P and S. Now, where do I get my information for here, for my 3 points, P, R, Q? How do I know what height they are?
From the line.
Yeah, they're on the lines. So P is on 80, Q is on 70, and R is on 75. What's the lowest of those numbers? Owen?
No, Q.
Q is the lowest at 70, so therefore I'm going to put this here. So the x1, y1 now is actually 70 meters above sea level. Does that make sense? And then I'm going to put dividers, or horizontal lines of 5s. 5, 10, 15, 20. There's the height of 75. There's 80. There's 85. Q is 70, which is here. R is 75, which is here. And P is 80, which is here. That should end up or equal an angled line, shouldn't it? Yeah? That angled line, if I identify that by putting it in here like this, that is the dip. Okay? If I asked you for the table, I asked you for the thickness of the table between the head wall and the foot wall, yeah, they're parallel to each other, aren't they? So we know that S is 85, so it's up here, isn't it? I might just zoom in on this because it is, I suppose, quite small. Might make a little bit more sense if I zoomed in. I should have zoomed in earlier on. But R here is 75, Q is 70, P is 80, S is 85. That's my foot wall, just the bottom of the wall, okay, or bottom of the table where it meets the floor, and then the head wall is the top. So therefore, it must be parallel to it. So if I take this line and I slide it down to S, I draw that parallel line. Take another coloured pen, put in an arrow, and say thickness. You're showing it off. Does that make sense? Okay? And that's that part. That technique there, guys, of that triangle where you take this line. This is a horizontal line. The strike is a horizontal line. It's like the top of your picture frame or picture on your wall. Okay? When you look at it, you want your pictures on the wall in your house to be horizontal. When we look along that, we do get the edge view. When we talk about dihedral angle, guys, okay, dihedral angle, if you look at this as a point view, you get the edge view of the plane, which is the angle of inclination, and that is part B of that question.